built-in dial gauge and thermistor. 2. Foam insulator. 3. Thermoplastic elastomer tubing 6.4 mm. 4. Steam generator. 5. Digital ohmmeter. 6. Wires. 7. Container for draining water. 3. Introduction and Theory. 1. Most materials expand when heated if no phase change occurs. 2. Heating increases atomic vibration and average separation. 3. For a tube of length L and temperature change delta T, the length change delta L is proportional to L and delta T. Equation delta L equals alpha L delta T. Symbols. 1. Alpha equals coefficient of linear expansion. 2. Delta L equals change in length. 3. L equals original length. 4. Delta T equals temperature change. Experiment note. In this experiment, measure alpha for copper, brass, and aluminium. Main title, Experiment 14. Thermal expansion coefficient of linear expansion. Solid tube heating, a metal tube increases its length. The change in length depends on the original length, the temperature change, and the material. 4. Measuring length. Measure L between the outer edges of the stainless steel rings. Steps 1. Measure L at room temperature. 2. Measure from the outer edge of one stainless steel ring to the outer edge of the other. 3. Record the value in Table 1. 5. Equipment setup. Main parts. 1. Contact indicator/dial gauge. 2. Stainless steel ring. 3. Capture spring. 4. Thermistor. 5. Slotted mounting block. 6. Stainless steel ring. 7. Thermal rod/tube. Thermistor lug side. Detail 1. Capture spring. 2. Thermistor lug. 3. Foam insulator setup. Steps 1. Mount the copper tube in the expansion base. 2. Attach the thermistor lug near the middle of the tube. 3. Place the foam insulator over the thermistor lug. 4. Connect the ohmmeter to the thermistor banana plugs. 5. Attach the steam generator tubing to the end nearest the dial gauge. 6. Place a container under the other end to catch draining water. 6. Procedure 1. Measure the tube length L at room temperature. 2. Mount the tube in the expansion base. 3. Attach the thermistor lug and foam insulator. 4. Connect the ohmmeter and record room temperature resistance RAM. 5. Connect the steam generator tubing and position the container. 6. Zero the dial gauge, then turn on the steam generator. 7. When resistance stabilizes, record ROT and the expansion delta L. Repeat for brass and aluminum tubes. Notes 1. Each dial gauge increment equals 0.01 mm of tube expansion. 2. The indicator needle moves counterclockwise as the tube expands. 7. Observations in data table columns. 1. Material 2. L millimeters. 3. RRM ohms. 4. Delta L millimeters. 5. R H O T ohms. 6. T R M degrees Celsius. 7. T O T degrees Celsius. 8. Delta T degrees Celsius. Materials 1. Copper 2. Brass 3. Aluminum. Note. Convert thermistor resistance to temperature using the thermistor conversion table. 8. Calculations. 1. Convert RRM to TRM. 2. Convert RHOT to THOT. 3. Calculate delta T equals THOT minus TRM. 4. Use delta L equals alpha L delta T. 5. Rearrange to find alpha equals delta L over L delta T. 6. Calculate alpha for copper, brass, and aluminum. 9. Results/key takeaway. 1. Heating causes measurable tube expansion. 2. Different materials have different coefficients of thermal expansion. 3. The experiment compares copper, brass, and aluminum using measured delta LL and delta T. 4. Accurate setup and temperature measurement are essential. 10. Visual summary/final note. Thermal expansion shows how heat changes the dimensions of matter. By measuring length change and temperature change, we can determine the coefficient of linear expansion.